Welcome everyone. Let's talk about root development today, and let's jump right into it. So, what is root development? First, your crown has to be complete. After your crown is done, then we will form the root. And just to recap, we have done our tooth development, which is basically your initiation stage, your dental lamina, and then it goes from the dental lamina into the bud cap bell stage. And then finally we have the eruption. So if we talk about root development, let's talk about the cells. So cells of root development are basically everything that is forming the tooth. So you have the enamel organ, which originates at the cervical loop. You have the dental papilla, which forms the pulp. You have the follicle, which will form the PDL, cementum, and the alveolar process. So all of the cells contribute to that. And if we just talk about the cells from our previous tooth development, we know that we have these outer enamel epithelial. We have the stellate reticulum. We have our ameloblast, which will lay down the enamel and purple dentin. And then on the other side of dentin, we will have odontoblasts that are laying down dentin. And then finally, we have the pulp. We have the epithelial diaphragm, which forms right at the corner, at the tips, and it kind of does a bend towards the root. So we have the apical foramen, or the canals and arteries will enter the pulp. Oh, I forgot the stratum intermedium. Stratum intermedium, and that is basically right on top of the enamel cells, and they provide the nutrition for that. So, where do all the cells for root development come from? It's the enamel organ, which will form the enamel, the papilla, which will form the pulp, and the follicle, which forms out of the periodontium. Then we'll talk about the root sheath. So, the root sheath, what happens is you have cell proliferation that happens at the cervical loop. Cervical loop is where the inner and the outer enamel epithelial meet at the apex, basically, of tooth formation. And then once they meet after the crown is formed. So after crown is formed, with no input of stellate reticulum or stratum intermedium, both of the inner and the outer enamel epithelial will meet, and that starts root sheath or root development. Another concept we have is Hirsch, and that is the Hertwig epithelial root sheath. It is a epithelial bilayer that covers the root of the connective tissue, and the epithelial diaphragm is part of the Hertwig epithelial root sheath. So epithelial diaphragm is the most apex point, so it is the bend in the root, and it is part of the Hertwig epithelial root sheath. So how does it form? We know that the epithelial diaphragm, which is the most apex region, has to form before the lateral walls or the lateral component of the root. This might be an odd concept, but we would assume that it forms from top down. You would have lateral component, which forms into epithelial diaphragm, but it's actually that epithelial diaphragm forms before the lateral root. So what are the steps of forming this epithelial diaphragm? You have the cervical loop, which goes under mitosis, and the cervical loop, as it's elongating, will bend under the crown. That gives you your epithelial diaphragm component of hers. That's where the inner and the outer enamel epithelial meet, and forming of this bend or the epithelial diaphragm gives you your apical foramen and the root canal, where the nerves and the arteries will flow into. So that is basically all of root development. We will start with how to form one root. We will talk about how to form multi-root, and then we'll talk about hers and some anomalies. So let's talk about how to form one root, single root. Sorry, I'm having a technical problem real quick. Okay, so this will be our kind of outline. Started right here. So we will do one root, then we'll talk about how to form multi-root, such as in the molars. And then we'll talk about the Hertwig epithelial root sheath, and then some anomalies. So one root, two root, Hertwig epithelial root sheath, and the anomalies. So what are the cells? First is the cells that form the root. And we know that all of these come from every component of the tube. So you have the enamel organ, you have the dental follicle or the dental sac, and then you have the dental papilla. And respectively, these will form the enamel as we know it, and the origin of that is at the cervical loop, which starts root development. We have the dental sac, which forms the periodontium, and the papilla, which will form dentin and the pulp. And we know the dental papilla is the one that is the ectomesenchyme origin, whereas enamel organ was the epithelial or epithelial origin. Then next we go into the root sheath. So the root sheath is basically found at the cervical loop, and this is where the outer and the inner enamel epithelium. So as the tooth comes down, as the crown is formed, you have this basically layer of inner and outer enamel epithelial. So this is your cervical loop. And at this point, you have this cervical loop proliferation that happens, or the connective tissue proliferation that happens on the cervical loop, and that will cause the root to grow. But that only happens after the crown is complete. So crown has to be done first before we can start forming the root. So the root sheath, the importance of the root sheath is basically that it is what determines the size, shape, length of the curve. Size, shape, length, and the curve of the root. It also is what starts root development. So the question could be, what initiates root development? It's your root sheath. The Hertwig epithelial root sheath, on the other hand, is the extension of the cervical loop, and it is a bilayer epithelial tissue. So now let's talk about what initiates, or the inductive steps of root formation. So at first we have the formation of the root in the cementum. So what happens here is that you have your ectomesenchyme cells from the dental papilla that contact the inner enamel epithelial cells of the Hertwig epithelial root sheath. They interact and they initiate or differentiate into the root odontoblasts. And those root odontoblasts, just like our other odontoblasts, will start laying down root dentin. So our dentin is the first one that is formed. Then we go into enamel proteins. And an enamel protein, so basically we have to form enamel next. You have this amelogenin, which interacts with the cementum of the crown, and that will form the outer covering of the dentinal tubules, which initiates the start of cementum or root cementum. So we have started making cementum, and we know with cementum the PDL kind of also start attaching itself or developing and attaching. Then finally we have the breakdown of hers. And in breakdown of hers, due to this pretty amazing concept that the epithelial cannot keep up with the connective tissue growth. So the epithelial cells break off. And as they break, the cells are stretching, and as they break, you have these epithelial cell rest of Malisae, which basically are islands of cells that came off that epithelium that's kind of proliferated. So you have this break, and you have some type of exposed dentin after that, or exposed cementum after that, of the root. So those are basically floating in the PDO space, if you want to think about that. Future, that comes in handy. And then finally, let's talk about the cementum and PDO once again. So quick, let me erase something here. Questions? So how do we form cementum and PDO? Basically, we will go into the dental sac cells. They're able to migrate into this, through this epithelial cell rest. It's basically through epithelial cell rest of Malisae. And once they contact your dentin, you will start secreting cementoblast, which will make cementum, as well as basically cementum and your PDO. So cementoblasts, more detailed, they secrete cementoid, which is the inorganic layer basically that's made up of the collagen and the GAG, glycosaminoglycans. These are your extracellular matrix. And then cementoid, with the help of hydroxyapatite, the mineralization component, will form your cementum. This is just this process in detail. Okay, so we have formed the cementum PDO, we have formed the root dentin, and that's all that's in the root. So we have the dentin, root cementum, because enamel is only in the coronal region. Okay, so next step is basically what differentiates something being single-rooted or two or multiple root, and that is all dependent upon the epithelial diaphragm. So epithelial diaphragm is the only thing you have to know that decides the number, the size, the shape of roots. And so these tongue-like projections, whichever way they kind of go together and spread out, that's how you form different angles in the root and all that component, basically. If we talk about hers, hers is the so hers, like we said, was the extension of the cervical loop, and we will talk about what it is and how it forms. So you have basically proliferation of these outer and inner enamel epithelial cells that's happening both sides, and then they go into a bend, and after that they stop, and on both sides you have this bend of the epithelial diaphragm and then the lateral component. So let's talk about the steps. We know it's a bilayer of epithelial tissue and covering the connective tissue origin or component of the root. And the proliferation happens first is that you have this mitosis at the cervical loop. And then after that, as the mitosis is happening, it's going more apically. You have the cervical loop, which is able to bend, and that forms your epithelial diaphragm. And that's why epithelial diaphragm is part of hers. We say it's a part of hers. Third, we have basically the bilayer epithelial diaphragm, which is formed, and that is also once again inner and outer epithelial. And then finally, both of the epithelial diaphragms on either side gives you your root canal or your apical foramen. So if you look in this simple drawing, this is your apical foramen. If you look at a tooth from the bottom top, if you look into basically in the maxilla from above, you see the tip of the root. So this is your apical foramen. Everything around is your epithelial diaphragm. Next, we talk about some type of anomalies that are associated with root development. A little bit more space. Okay, so what are the anomalies? What is anomaly? It's just a mess up in a formation. So the anomalies that we will just talk about are your enamel pearls, your accessory canal, and then the exposed dentin. And all these can have impact on your patients. Like accessory canals can spread infections. Then enamel pearls can make your extraction harder, and so on and so forth. So let's start with the first one, enamel pearl. In enamel pearls, what happens is that if you have a break in if you have a interruption in the root sheath development, you will get some type of anomaly. So if you have the amelogenin or the epithelial that interacts with the cementum, it will form this enamel pearl anywhere in the furcation or in the cervix. You can have the accessory canals that form when you have a break in the epithelial diaphragm. Break in the epithelial diaphragm, and these canals basically form at a 90-degree angle and can be a risk of infection. So we know that before root sheath, what's important is that before root formation, root sheath must be present. And if there's any kind of interruption, that's what leads to these anomalies. So that is it for root development. We talked about single roots once again. And single roots, basically, you have the cells, which are basically all the cells of the tooth, enamel organ, dental follicle, dental papilla. What's important in making the root is the root sheath, and as the root sheath grows, it kind of bends and forms this epithelial diaphragm, as well as the future apical foramen. And then we have a few inductive steps of forming at first the dentin. So your ectomesenchyme from your papilla, as well as the inter-enamel epithelial cells of hers, they start secreting odontoblast, which secretes dentin. Then you have amelogenin, which is your enamel protein, with cementum forms the outer dentinal covering of the dental tubule, which starts cementum. Then, due to the fast growth of connective tissue, so epithelium cannot keep up, you have the break in the epithelial that forms the epithelial cell rest of Malisae. And that's important because you can have these collagen fibers now that can interact with that cementum of the root and start forming cementum. So dental sac cells migrate through those cell rest of Malisae, contact dentin, lay down cementoblast. Cementoblast made up of the cementoid, which is your collagen and gag. With the help of hydroxyapatite, will start laying down cementum, which also starts the PDL fibers. The only thing that differentiates what forms a single root and multi-root is basically the epithelial diaphragm. And then we talked about hers. Hers was the bilayer epithelial, and it has mitosis that happens at the cervical loop. Then it bends, forms the future apical foramen or the root canal. And finally, anomalies, which can be cause of the root sheath, and you can have enamel pearls, accessory canals, and exposed dentin. Now we will just do some question types. So I will hold it or highlight the question, then I'll slide over to the answer, and then I'll slide back to the question.